Okay, let's get into this. We're looking at a piece of pro gear today that almost seems to cheat physics.
It really does.
It's the Thor broadcast F-1V2A-TxRx-RM, and it's built to solve one of the biggest nightmares in broadcasting.
Yeah, how do you move a perfect signal from one place to another when they're miles apart?
Exactly. Our mission for you is to really understand how this fiber optic unit pulls it off, moving broadcast quality video and audio over, what, 20 kilometers?
20 kilometers. And the hook here is that uncompromising quality. We're talking about making sure there's zero signal loss, no static, no blur over 12 miles.
It's a huge ask.
For professional broadcasting, signal noise just isn't an option. This is the fix.
So let's start with what goes in. The specs say one channel of video and at least two channels of analog audio.
Right.
But the video isn't just any video. It's specifically CVBS composite baseband.
And that detail is it's crucial. When we say CVBS, we are not talking about your modern compressed HD stream, not at all.
We're talking about something much more fundamental.
We're talking about the raw, original analog signal.
Yeah.
The standard for legacy broadcast feeds, some high-end CCTV, that kind of thing. It's a very delicate signal.
So if the source is that kind of old school analog, how on earth do you protect it for 20 kilometers? This has to be where the magic comes in, the 12-bit digital transmission.
That's it. That's the whole engineering marvel right there. Before that signal even touches the fiber, the unit digitizes it.
Yeah, okay.
And standard digital video that often uses 8-bit encoding,
Mm-hmm.
which gives you about 256 levels of brightness or color it can see.
And what does 12-bit give you?
You're jumping from 256 levels to 4,096.
Wow.
And what's so fascinating is that this kind of precision, this 12-bit digitization, it's usually saved for super high-res modern content. Applying it to a composite signal might even sound like overkill.
But it's not.
It's not overkill, it's robustness.
Ah, I see the logic now. So you're not using those extra bits to make the picture sharper. You're using them to capture every single tiny nuance of the original analog signal.
With such precision that noise just can't creep in later.
It's like scanning a priceless old photograph at the highest resolution you possibly can, just to preserve every single detail and imperfection perfectly.
That is a perfect analogy.
Yeah.
The source gets digitized at 12-bit precision, and here's the other key. It's then sent as an uncompressed digital signal.
Uncompressed, so zero data loss?
Zero. It's modulated light, shot over a single strand of single-mode fiber, which you need for that 20-kilometer distance.
So it's basically a high-fidelity digital tunnel made of light, and it only goes back to analog when it hits the receiver on the other side.
That's right. And, while it's made for broadcasting, that level of precision makes it perfect for video over fiber test systems, too. It's built to be trusted.
Right.
And for the pros who are using this, you get that 20-kilometer distance. It's TAA compliant, and it comes with a 2-year warranty, for peace of mind.
So what's the big takeaway for you here? This device is on a very specific mission. It's all about moving high-fidelity, uncompressed analog signals, and it can handle up to 8 channels of audio over really big distances.
And it's that specific power of 12-bit digitization that makes the connection immune to all the noise and static that would normally kill a long analog run.
It's just silent assurance that your signal stays perfect.
No matter how far it travels.
And that leaves you with a really interesting question to think about. What's the unique engineering challenge in keeping a signal totally pristine and uncompressed over 12 miles? The answer is in that very specific and probably very expensive choice to use 12-bit digitization, not for resolution, but just for bulletproof noise immunity. Think about the investment needed just to protect those extra 4 bits of data.